If you think about it for a second, the task of building a precision machine is actually fairly simple. All you really have to do is maximize rigidity and nail alignment, and you should end up with something that goes exactly where you tell it to, no matter what you put in its way. But if you think about it a little bit longer, and maybe even give it a go, you're probably going to realize that while the design aspect of a project like this is one thing, the execution usually ends up being a few dozen other things entirely. Now look, just a quick disclaimer. This video probably isn't going to teach you everything you need to know to build a machine like this yourself, and there's a few good reasons for that. First of all, despite the project at hand being deceptively complex in its own right, I'm talking everything from metallurgy to pneumatics, chemistry, and even a little bit of thermodynamics. We're not actually, technically, going to be building an entire precision machine today. Second of all, and maybe you already knew this, but I'm not an engineer, so there's a good chance that I don't actually have any idea what I'm talking about. Anyway, we've got a lot to get through, so let's get to it. Now there's a whole lot of problems with my homemade milling machine, but the good news is I'm pretty sure I think I know how to mostly fix at least one of them. I'm talking about the head. The most immediately obvious issue might seem to stem from the fact that it's not actually attached to the machine. But for the sake of this narrative, we'll assume that it is, while simultaneously, for the sake of brevity, I'll assume your understanding of a CNC milling machine's sole purpose at the most basic level, to maintain the relative position of a cutting tool to a workpiece, as and when instructed, down to mere fractions of a kilometre, down to mere fractions of a metre, down to mere fractions of a millimetre. Hopefully. I could say that technically this machine meets those criteria, although I have to admit I'd be a lot happier with myself if it didn't complain about it quite so much. See, when I first designed and built this part of the machine, an uncharacteristic lack of narcissism led me to believe that I couldn't possibly make it perfect. Therefore, in order to get the spindle aligned to the bed, I had to make it adjustable, and as a result, cutting forces from the spindle have to traverse a garden path of fasteners and switchbacks before they've even reached the column, by which point the total lack of rigidity has managed to destroy the part, my hearing, and all of my tools. Of course, this cereal box spindle definitely shares some of the blame. So I'll also be switching that out for something with a little more mojo. In a perfect world, the head would be made of a single piece of cast iron, like you might find on a real machine. Unfortunately, despite popular belief, I'm just shy of being a complete lunatic. So hopefully with a few clever tricks and an infinitely more direct load path, a welded steel construction should do just fine. If you like direct loads, you should like the video. And if you subscribe, I'll know you want to see more. As a bonus, it should do a nice job of using up this 12mm plate I've been moving out of the way for several years. But before we get to any welding, let alone clever tricks, I still had to figure out how I was even going to cut it up. As you might imagine, there's an almost impossibly diverse collection of strategies that one might adopt to complete this task. The original plan was to just bolt the entire plate to the CNC mill and hit the cycle start button, but this spindle had really started giving me the willies. So through careful consideration of all the other various methods, I landed on the bandsaw as the obvious choice. And I know you're probably wondering how I reached that conclusion, given the fact that, aside from its obvious elegance, in its current configuration, my bandsaw isn't exactly up to the task. But I mean, what's the point of a shed full of tools if you can't occasionally spend a little time making even better ones? Naturally, this left me with one option. Spend a completely justifiable amount of time upgrading it. I figured the drill press that's been sitting in the garden for 2 years would make the perfect foundation for the upgrade. And with a bit of questionable facing, a few holes and a weld or two, this square tube will be the basis of all the bracketry and connections holding everything together. This plate goes between the bandsaw and the square tube and serves to lock it in the vertical position, with some level of adjustability of course, while still allowing a full 90 degrees of rotation for when I inevitably decide I'd like a horizontal bandsaw again. But for now, it was the allure of a sliding table I was chasing, and with linear bearing mounting provisions, a rather satisfying machine making itself moment, and a fence to tie it all together, this collection of components certainly satisfied. Now, there's no doubt that I cut some corners here, but with any luck, it should hold up at least long enough to get us through this project. With the bandsaw finished, I was all set to get cutting. I just had to lay out my parts and I didn't have enough. Classic move, right? No big deal though. I could just order a little more and be on my way, except this momentary pause, afforded by my overestimatory tendencies, gave me the chance to realise that in the interest of avoiding yet another do-over on this part of the machine, I should probably go with something a little more substantial than the all too convenient 12mm plate I had kicking around the workshop. So I made the necessary adjustments to my design, opting for 16mm stock. But just as quickly as I went to place my order, I was stopped dead in my tracks by the same sticking point that always seems to delay these projects. The steel I needed was only about $100, but it was slightly beyond the cargo carrying capacity of my only mode of transport, which meant another $150 for a visit from the steel truck. Now, I'm not an accountant, but there's something about that ratio that just doesn't feel very sensible. After all, the whole point of building a machine yourself is to save money, right? In the past, I've managed to get around this issue by just ordering a surplus of material that I think I might need, quite effectively deluding myself with the perception that it's not that much added cost. This time I finally managed to overcome the pattern of procrastination and subsequent overspending, and the allure of on-demand access to the steel supplier led me to the very sensible and financially responsible decision to requisition a cargo carrying workhorse of my own. This bad boy can fit so many tax deductions. By this point, you're almost certainly shaking your fist at the screen and probably wondering to yourself, when is this guy going to shut up and actually start building a precision machine? That's a fair question, and one I'd pondered myself at least once or twice. If you'd told me I'd have built a bandsaw, bought a lemon, and taken on a mechanical engineering intern, all before even laying out a few cut lines, I'd have said, yeah, that sounds about right. So we'll quickly move past the brief moments of despair and remorse immediately following my second-hand van purchase.
Do you want to talk about it?
My triumphant trip to the steel shop.
I mean, these aren't really doing anything. At least I tried. That's all that counts.
And what's that? Oh, the intern? Yeah, best not to make eye contact. Once I had my hands on the elusive 16mm plate stock, marking the cuts was a simple game of Tetris. Then it was over to the shiny new sliding bandsaw table to free each piece from its scaly tomb. Despite my upgrades to the saw, a bit of manual intervention was still required to flip the plate on some of the longer edges. But looking past the barely adequate throat depth, I couldn't be more pleased with the quality of the cuts. This thing might as well be a laser beam. In fact, cleaning up the saw cut edges was easier than the laser cut edges, and they only needed a few hundredths of a millimeter off the top. Of course, there's still plenty of room for operator error, and just because the cuts were straight, didn't mean they were in the right place. Luckily, I'd left myself just enough material for a near enough is close enough type arrangement, so I decided the best way forward was to tack things up and machine the faces along the way. But the final few parts of the fabricated component of this puzzle had some features that even a bandsaw of this caliber couldn't handle. so it was over to the mill for yet another tired demonstration of why I'm putting myself through all of this in the first place. I quickly put the machine to work, profiling the rear plate and drilling a mix of mounting holes and entry points, which should make roughing the cutouts a little less painful. But not by much. I was a bit rusty on the old cam side of things, and spindle was starting to feel like too strong of a word for whatever the fuck this thing was trying to be. Although I take full responsibility for running a 6mm toolpath with an 8mm end mill. Guess who just ran a 6mm toolpath with an 8mm tool? I thought of a saying yesterday. Knife makers don't make mistakes. They just make smaller knives, and well, pretty sure this thing's just a big spinning knife. Let's just make it a bit smaller. Making the part ever so slightly lighter than it should have been. The riser blocks, started off a little better. Which is to say, it ended in the same way. At least this time, it became clear that at least part of this massacre was down to the collet chuck and its defiant refusal to hold on to the tool. I'll teach you to pull out. But breaking yet another end mill, and yet another, and yet another, wasn't enough to break my resolve. In fact, these setbacks only served to remind me of the final goal, of the unbridled, burning desire for zero runout and absolute rigidity. I know more than a few of you will be questioning the decision to weld this part, pumping a huge load of heat into what's supposed to be a precision component. And you're right to be concerned. For those of you out of the loop, when a weld cools, it experiences a substantial amount of shrinkage due to a phenomenon known as the Costanza effect. The force exerted by this shrinkage can easily exceed several tons, inducing all kinds of internal stresses in the weldment. And while that might not be a huge problem now, these stresses can evolve over time, and it'd be really nice to know that once I've machined, scraped, and lapped all the mating surfaces, they won't suddenly decide to try something new for a change. Now, there's a couple of ways to approach stress relief. The first is known as VSR, or vibratory stress relief. The basic gist here is to shake the shit out of the part, but it's not quite that simple. Because every weldment is unique and beautiful in its own way, requiring a carefully calculated set of parameters to achieve the desired effects. But I'm not one to let calculus get in the way of a good time, or even really have any idea what calculus is, so I figured it wouldn't hurt to have a blind stab in the dark. Unfortunately, I wasn't really convinced I'd actually achieved anything. Thermal stress relief was option B. By slowly and evenly heating the weldment to around 600 degrees, the steel becomes soft enough that all the internal stresses are eliminated. Now, as exciting as I'm sure it'd be, unfortunately I haven't got any footage of the actual process, because the temperatures required for stress relieving steel tend to have a bit of the opposite effect on humans. But Dave and his self-proclaimed ugly mug was more than happy to give me a look around the workshop, as well as share one or two decidedly entertaining cautionary tales.
Got water-cooled bearings. Yeah. One of the fucking hoses blew.
With the stress relief blissfully out of my hands, I could finally turn my focus to the business end of this build. The brand new BT30 spindle cartridge with automatic tool change support that I really wish I'd gone with in the first place.
And then in went the spindle.
Or the second.
Then out came that spindle, and in went this one.
Or even the third.
Not only did it suck, it really sucked.
Yeah, this is the fourth time I've convinced myself that a spindle upgrade is just the cure-all I need. But you know, my stubborn rejection of the conventional wisdom, to buy once and thereby cry once, has led me to another, equally profound discovery, that there comes a point when the severe overuse of my tear ducts has rendered them completely inoperable. Anyway, all that matters now is getting this absolute unit mounted to the machine. Some of the more observationally inclined among you will have noticed a distinct lack of spindle mounting provisions on the equally hefty chunk of steel we sent to the sauna. See, while I have total confidence in my ability to achieve the perfect alignment of flat surfaces, I can't really say the same when it comes to holes. The solution here is to mount the spindle to a separate collar, which can then be bolted to the riser. Of course, I'll still have to nail the alignment front to back, but it'll make tramming the spindle left to right a whole lot easier. I know that completely contradicts my whole spiel about bolted connections and garden paths, but just like I said to myself the last time I restocked on end mills, this time it'll be different. This has a little to do with the fact that I designed it to be machined from a single monolithic piece of material, and a lot to do with the amount of surface contact that allows for. But before we dive into the surprisingly simple methods used to achieve that perfect fit, we need to address a few other features, like the pneumatic drawbar system, and even before that, I still had to face the challenge of sourcing a chunk of steel that big, let alone pulling a functional part out of it. You know, I was sort of starting to think that maybe this project wasn't so simple after all. At least that would have been the case if it wasn't for PCBWay, the sponsor of today's video. Because aside from being a leading manufacturer of custom printed circuit boards, did you know they provide an extensive range of CNC machining services as well? From laser cutting and sheet metal bending, all the way up to 5-axis milling and turning. PCBWay has the CNC machining capabilities to take the hassle out of even the most monumental projects. So all I had to do was upload my CAD file, tick a few boxes for things like material selection and surface finish, and before too long, I had an incredibly specifically shaped 11 kilogram block of 4140 knocking on my front door. Now obviously the most important feature here is the spindle bore, which is a beautiful locational clearance fit by the way. But when you're not the one tapping them, peppering parts with threads like this is trivial, and it'll give me a lot of options for mounting future accessories, like coolant lines, probe arms, or even cup holders. Not to mention the pneumatic cylinder, which we'll be adding next. And this might be a little bit over the top, but I also managed to find the space for a coolant chamber, as well as the passages to supply it and the O-ring grooves to seal it. Oh, and the process was just as easy with this other part. This time in aluminium and with a beautiful anodized finish, which will probably make a little more sense later in the video. But we'll get to that when we get to it. Huge thanks to PCBWay for sponsoring yet another ridiculous project and making the hard parts simple. Click the link below to find out more. And now back to our regularly scheduled Until It Isn't. Having the shiny new spindle collar in hand gave me the opportunity to finally start on arguably one of the most important aspects of this build, mounting the pneumatic drawbar cylinder. I'm not going to get too deep into machine tool taper theory here, but the general consensus seems to be that sending tool holders across the workshop at Mach 3 is best avoided. Thankfully, pretty much every milling machine has some sort of drawbar, aptly named for its responsibility of drawing a tool holder up into the spindle. On manual machines, it's usually accomplished with a pair of matching threads. It's hard to argue with the simplicity of this method until you try to get a machine, distinct in its lack of opposable thumbs, to change tools for you. Okay, Mill. Fly cutter.
Sorry, I can't do that right now.
So on spindles designed for machines with a mind of their own, we'll find a slightly more spring-loaded solution. In the case of the BT30 standard, the business end of the drawbar features a set of expanding pawls, which, when drawn upward with the help of a little spring force, close around the stud on our tool holder and pull it up tightly into its taper. Then all we have to do to release the tool is press down on the drawbar with slightly more enthusiasm than the springs pulling it up. And when paired with an electronically controlled valve, pneumatic cylinders are a fantastic way to do it. Especially when you've already got one that you're pretty sure will do the trick from the last time you tried this. One must imagine Sisyphus happy. Now I mentioned adding all these holes to the collar to give myself plenty of mounting options, but it still took a little more chin scratching than it probably should have to land on this design. And despite its undeniable aesthetics, you might question the use of a 3D printed part in the presence of loads exceeding 300 kilograms. Thankfully, it really only serves to locate the cylinder, with all the load being transferred through a couple of threaded rods. Parts like this are exactly what make 3D printers so useful in the machine shop. Not too long ago, Bamboo Lab sent me an X1 Carbon, and it's completely changed the way I think about prototyping. But at the end of the day, there's only so much you can get done with a single printer. So when they offered to send me its little brother, the P1S, I obviously said yes. But what I didn't expect was a machine that was just as fast, capable and hassle-free for like way less money. it was finally time for the new Spindle's first ever pneumatic tool change. And I can't overstate my excitement leading up to this moment.
Very, very rough test.
Nor my disappointment immediately following it.
That sucks. It's not strong enough. I should have known.
I won't dwell on the specifics of this failure, but apparently I'd severely underestimated the force necessary to fully compress the drawbar springs. But in a way, this was good news, because it absolutely crushed any doubt about whether or not the spindle would be able to hold on to tools. And the solution was as simple as just adding more cylinders. Except, for some reason, multi-stage cylinders are kind of expensive. And even if I was able to amalgamate a couple of the cheaper single-stage variety, I'd have to wait a couple of weeks just to make an attempt. But really, these things are just a few cylinders and a collection of O-rings. So I said fuck it, and decided to knock one up myself. This decision was helped along by the fact that I had the perfect piece of aluminium, which was just big enough for 2 separate pneumatic chambers and an array of seals. After a hefty amount of stock removal, I gave the cylinder head and main body matching threads, but while attempting the same for the butt cap, I completely blew it.
Oh no.
So I decided to retain the butt cap by way of a groove and clip. Unfortunately, I wasn't filming when I decided to test it, so you'll just have to believe me when I say that this wasn't my brightest idea. And so to avoid the possibility of further ballistic incidents, I switched track to a more comfortable arrangement of high tensile fasteners. Then I could finally take care of the pistons, the shaft, and a bit of precarious porting.
Did it.
Before we get to assembly, I can't overstate the importance of a clean workspace when working with pneumatics. Even the smallest piece of debris could render our seals incontinent, so I like to make sure I've pushed all the junk on my bench out of the frame. Predictably, the new cylinder was completely incompatible with the old mount. And having already gone to all the trouble of making the cylinder from scratch, I decided to take the fresh start as an opportunity to add another layer of complexity. I'll try and keep this quick, but the goal is to prevent the force from the cylinder slamming into our nice precision spindle bearings every time we change tools. By pulling on the spindle shaft rather than its housing, we'll figure out a way to keep it located eventually, but the anticipation of a test run was too much to ignore, so I connected the solenoid valve and let it rip. Success! But just the tip, and only for a second.
Uh-oh.
Because it just barely had enough power, and only when the compressor was at its maximum pressure. A rare occurrence, given the point at which the motor kicks back in. Before you say anything, yes, I did try messing with the pressure switch to raise the motor start pressure, but unfortunately, that also affects the cutoff pressure, and I'm not too keen to find out what happens when we exceed the tank's pressure rating. Fortunately, while browsing eBay for used industrial components, I came across a get out of jail free card in the form of a very fairly priced booster regulator, which, once I figure out where to actually put it, should be able to raise and stabilize varying pressure from the compressor to a consistent megapascal. Of course, it was in Tasmania, so the international shipping took a week or so, but spoiler alert, it actually works. I still haven't wrapped my head around its borderline occultist inner workings. All I know is it makes a pretty sweet sound. But we should really get back to that riser. After getting it back to the workshop, the first step was to get rid of all the scaly oxide formed in the oven. A bit of vinegar probably would have been the trick here, but instead I decided to use a can of Evaporust gel, which actually did a pretty decent job, except for the part where I left it too long, allowing it to dry up and cake every nook and cranny in probably the most stubborn gunk I've ever come across. It wasn't overly difficult to scrub the outside clean with an angle grinder, but the inside was a different story, thanks to some genius welding in a labyrinthian array of studs. Sadly, this wasn't something I could look past. A strong bond between the secret sauce and steel was essential, yet completely impossible, as long as every inch of the surface remained caked in shit. But where even a poorly devised drain snake fails, half a bag of gravel, a frighteningly unbalanced rotating mass, and a potentially adequate blast shield are sure to bring success. With a distinct lack of incident, the improvisatory vibratory tumbler had worked wonders. So propelled by the thrill of machining a not inconsiderably sized part on a definitely could be slightly larger mill, I got to work adding features. After facing the spindle mounting surface with the fly cutter, I switched to an end mill to square the sides and added a pair of slots and a shallow pocket, which will make a little more sense later on. Without the space to fit a full-length drill, I settled for spot drilling the collar mounting holes and finished them up on the drill press. This also happened to be the point that I realised it was probably a bit silly to use M8 fasteners for this connection, and decided to step it up to M10, which did mean I'd have to open the holes on the collar a little bit, but that was a simple enough task. Anyway, when it was time to flip the part over, I came up against a resounding lack of travel on my manual machine. I thought I might be able to get around this by knocking up a nice big fly cutter to face the surface in one pass. This was kind of an absurd conclusion, reached due to a distinct lack of confidence in the not dead but dying spindle on the CNC mill. I just figured the more parallel I could get the faces now, the less pain I'd have to go through later. But it was going to be hard to get the faces parallel at all, if I couldn't even get to them. Plus there's something poetic about a machine making parts for itself, despite its shortcomings. So setting it up again, I attacked it with a fly cutter, only to be pleasantly surprised by the results. Then I added some relief around the mounting faces, which will make the next job easier, in the same way as this pocket from earlier. And then I could finally get to the exciting part, rubbing all the parts together, until I've got a perfect fit. Well, an almost perfect fit. Starting out with a simple piece of 120 grit sandpaper and a dash of lube, created a nice slurry of coarse abrasive, sandwiched between the two surfaces. But lapping is a pretty slow process, especially when you still haven't restocked on diamond paste, since the last time you realised how boring it is. And unfortunately the carbide scraper you'd slapped together to speed things up previously had apparently grown legs. But what's another quick tangent in a feature-length collection of the things? A quick T-slot and some grub screws turn this stainless round bar into the perfect receptacle for a planer blade, the only flat piece of carbide I could manage to find in a hurry. With a handle and the proper edge geometry, the material removal became much less monotonous. Certainly helped by the fact that we're not really going for flatness here, and even parallelism wasn't the biggest concern. Because in a lot of ways, the tram of the spindle would depend on tolerances that I started stacking all the way back when I decided to build this machine in the first place. No, the goal was as simple as maximum contact, and the process a simple matter of bluing the surfaces, scraping the high spots, then a quick bit of lapping to smooth things out, until I had a really generous transfer of blue. Of course, no amount of blue would tell me if the surfaces were actually where they needed to be. So it was time for a test fit. Pulling off the old spindle and head was a big milestone and not a bad motivator, mostly because it meant I'd be without CNC capabilities until I got the upgrade running. And while I'm not exactly running the thing every day, or even every month, knowing that I could at any moment is basically my entire personality at this point. The rear mounting pads weren't a completely perfect fit to the bearing blocks, but they were close enough for me to call the slight discrepancy preload. So after getting the collar and spindle into place, I took a measurement of the gap between the ball nut and its mounting pad, and happily moved on to its spacer block. The small mill wasn't loving the roughing, and the rain of blue hot chips showering my hand made sure that I wasn't either. But after finally remembering all that time I'd spent building the sliding bandsaw table for this exact purpose, I quickly had the bulk of the waste removed. Then it was just a matter of carefully creeping up on my target thickness. And once I was happy, a few holes and a couple of threads marked its completion. With the Z-axis finally moving under its own steam, it was time to see how much more scraping I'd have to do by measuring the spindle tram along the Y-axis. I can't tell you how enthused I was by this discovery, but I still had quite a few finishing touches to add. So I got straight to tearing it all down. Only briefly forgetting about the counterweight attached from the rear. Managing to narrowly avoid incident with the help of a passerby, I added the threaded holes for motor mounting, somewhere between the blind trust held in my inkjet printer and the second wobbliest spindle in my life right now. I managed to drill one of the holes a full millimeter out of position. Of course, I was getting pretty tired of lugging this thing around by this point, so whether it was an attempt to ignore my mistake or just a sense of blind optimism, I managed to avoid addressing the issue until it became a complete ball ache to do so, at which point 3 fasteners seemed more than adequate. But for now, it was time for some secret sauce. While the new riser obviously had the edge over its predecessor in terms of both rigidity and sex appeal, they still shared one critical flaw: dampness, or rather, a total lack of it. And no, that's not something you can solve with a bit of spit. Damping refers to a material's ability to dissipate vibrational energy, and steel is about as damp as a you-know-who's you-know-what. And with the shape of the thing, it was more like a church bell than a machine part. On the other hand, epoxy granite is as dead as a doornail, and twice as pourable. There's a lot of conjecture on the perfect recipe for the stuff, but the basic idea is to take a mix of aggregate, carefully graded for optimal packing density, and mix it with a bit of glue. The whole carefully grading part sounded kinda boring, and as far as I know, you can't buy the fancy stuff down here. But road base is only $13 a bag, so I put the intern on rock drying duty and got the part ready for the pour. I mixed part A with part B, then slowly added it to the gravel. The mix was about 10% epoxy by weight, and I made sure to use a deep pour epoxy with a slow cure, giving me plenty of time for mixing, and a good deal of panic over whether it's actually curing the following day. A bit of vibration helps the mix settle nicely. And once the cookie mix started to set, I topped it off with a little cream. At this point, it really felt like I was close to the end of the project, and I suppose in a way I was. But in another way, far more grounded in reality, I still had to take care of a whole lot of annoying little details, like mounts for the new drag chain and relocating the limit switch flags. At least they were annoying the last time, back when I first built the machine. Now I can just print them in glass fibre reinforced ABS. And another box from PCBWay had arrived, bringing with it this slightly gratuitous but beautifully anodized spindle servo mount. See, I'd experienced some overheating issues with the old setup, and while there was no doubt the acrylic motor mount might have had something to do with it, having already decided to liquid cool the spindle, I figured I might as well plumb the servo into the loop as well. The epoxy granite had fully cured by this point, and a few coats of paint and primer marked the completion of the riser. And with that, it was finally time to start putting it all together. I was definitely curious about the total weight of the new spindle assembly. So, for better or for worse, I opted to put it all together on the bench. I added a light coating of lanolin to the mounting surface before attaching the spindle assembly. And with its O-rings installed, the motor mount went together perfectly, except for the part where I forgot to order the correct hardware. But I was itching for a test run, so I pressed on with a few substitutes. I attached the spacer blocks next, then added a little thermal paste and the motor, which was a beautiful press fit. Once the pulley was installed, the whole lot could be bolted to the riser.
Oh my god.
With 3 of the 4 slots allowing the belt to be tensioned. The next step would have been to connect the spindle and servo cooling lines, but I was once again confronted by my own ineptitude, clearly displayed in the proximity of my port positioning.
Oh my god.
I guess the liquid cooling will just have to wait. With everything else assembled, and after a bit of lifting related contemplation, I could finally hoist the thing to see just how much gravity I'd managed to squeeze in. I was certainly pleased with the result.
Not bad.
A whopping 76 kilograms. That's almost 200 pounds if you squint and take a few steps back. Somehow I managed to get it attached to the mill without dropping it on my toes. And with that, it was time to find out if all those ups and downs had done anything at all to improve the capability of this machine, or if I just wasted the last 8 weeks of my life. But I'll let you be the judge of that. Of course, I still need to plumb the spindle cooling, and there's not much point to a pneumatic drawbar without an automatic tool changer. But I'll need to add a spindle encoder.
Are we going to say anything, or do you want me to just do it, whatever?
Just like maybe 5 seconds of nothing before.
Yep, 3, 2, 1, then I'll count it in 5 in my head.
Yeah.
Okay. 3, 2, 1. It's actually a really good watermelon.